I'm very pleased so I can show you today's presentation. It's about effects on response styles. So let's start by talking what these response styles are. Most generally, it is defined as using response categories disregarding their content. And more specifically, it's simply about overusing some response categories. Like, for example, middle category on the response scale, extreme categories, categories expressing acquiescence, and perhaps some other ones, yes? Also, we may think about response styles as some specific case of response biases that distort measurement due to some features, due to some actions of respondents. Most often, this phenomenon is studied with regards to self-completed questionnaires, but I see no problem in analyzing it also in case when interviewer was involved in collecting the data. Simply in such a case, response styles are effect of interaction between both respondent and the interviewer, and we cannot distinguish one from another. Second important thing is typically response styles are discussed in the context of rating scales, questions, and especially Likert type ones, simply because in this question format, what extreme or middle response category means is quite clear. In other formats, it may not be as clear. Also, mostly the topic was studied using psychological tests. So we want to make research on somewhat other grounds, in somehow other context now. Next thing, there are different ways we can think about response styles. What are those? And especially, we may think of them as rather stable individual traits, and then we often think of them as being continuous, or rather easily changing and contextual state. Then we think of it rather as a kind of categorical variable. Here we will assume this. We will take this first assumption. So we assume that response styles are latent traits, rather stable. But even within this approach, there are many competing most specific approaches, like there's no place to discuss them in detail. I suppose some of you may have heard about them, like IR3s promoted by Beckenholt, in which responding process is conceptualized as a sequence of binary choices. Otherwise, we may use multidimensional generalized partial credit models with a priori specified response styles. And recently, there is another approach using the family of so-called divide by total IRT models. It also uses GPCMs in estimation, but the way model is defined is optimized in such a way to get a better model fit, comparing to this with this a priori specified response styles. But this comes at the cost of more complexity of the model, and latent traits in this model have no natural obvious interpretation. Like we cannot say that this is trait responsible for distinguishing between people that are more likely to choose like a middle category or less likely to choose this one. There's meaning of this latent traits is not obvious there. Okay, so what we want to do in current research is to fill some gap, because response styles were studied up to now mostly as themselves. Yes, so if one can identify some, but it was not studied too extensively. What are the consequences of response styles to different types of statistical modeling? So some people looked at CFA or unidimensional IRT. There is also a recent paper on how occurrence of response styles affects a t-test comparison between two means. But these are very simple analyses, and we wanted to check how this affects something more complex. So we looked for, in a simulation, we looked for some worst cases that can happen in a rather simple SEM analysis. So we ask, firstly, can one reliably identify a probable data generating mechanism by comparing model fit? Secondly, what biases may be caused in the structural part of a simple SEM model by ignoring response styles, if they exist, of course. And third, whether using SEM involving response styles modeling mitigates these biases. And this is what we have studied in our simulation study. So we used a rather short scale with only 5 items. That is quite representative for sociological studies or large-scale assessment, when these these scales in the background questionnaire are often rather short. We used a 5-category response scale, so the perhaps most often used one. There were 1,000 observations, and we performed 1,000 iterations for each variant. And we used 5 variants of data generating model. Here you can see graphs. Only a structural part of the model is shown on these graphs. So first variant was no response style, so we simply have a trait. This 5-item scale is supposed to measure, and quite strong effect on an observable dependent variable. We assume that this dependent variable is simply observable, while trait is latent. And also we have 4 other variants that incorporated response styles. Of course, they were choose to make things worse. So in the first, there is the same effect of the same size between the trait this scale is supposed to measure independent variable, but there are also extreme and middle response style traits that are also connected with this dependent variable. And the structure of correlation between this trait and the response style latent traits is chosen in such a way that this effect of trait will probably fade out if we don't get these response styles into account. There were 2 subvariants here. We either used IR3 or the multidimensional GPCM in this measurement part as a data generating model. And last 2 variants were quite the same, but we supposed there was no effect of trait on dependent variable, and we changed the way latent traits are correlated to probably get this effect to come out as non-zero if we not take account, not take response styles into account. Okay, so these are how item parameter distributions of scores of items. So we generated items in such a way to get diverse easiness of these items. Models, in most cases, models converged. Okay, so as we estimated models using the same set of models we used for data generation, and moreover, we added this random threshold type. This is of this family of sum to zero models. And this type of models encountered some problems with convergence. And moreover, if data generating model was no response styles, higher trees failed badly converge. Okay, using BIC to determine the best fitting model provided perfect detection of the data generating model. So model with smallest diff was always this one that we used to happened to be always this one we used to data generation. AIC performed a little worse, but only for no response style data generating model. However, we are not sure whether these results generalize on conditions with smaller effect size, because well, our effect size in this structural part are quite strong, I would say. And now let's come to bias and confidence intervals coverage. Here you can see that with no response styles, in no response style conditions, all models all models do well, but no IR3s. And please bear in mind that IR3s have convergence problems in this case. And so simply, even if they converged, they gave results that were simply bad ones. In other conditions, the simple summary will be that if data generating model, data estimation model fits with data generation model, we have no bias. And if it does not fit, we get some bias, and we often get worse confidence intervals coverage. Also, one important comment, this random threshold, no, excuse me, this sum to zero model provided very poor confidence intervals coverage. And my comment is that this model is simply too complex to be used on a scale with only 5 items. Because on larger scales, it was shown in some papers that it works quite well, but with such a short scale, well, it fails. So now we want to turn from the simulation study to what we can find in PIAAC data. In PIAAC data, there is generally deficit of Likert type questions. Strictly Likert type are only 2 questions on generalized trust and a single one on political efficacy, but they do not form a reasonable trait altogether. So instead, we used a block of 6 questions on learning strategies. Well, one may assume that this is essentially unidimensional scale, so we measure whether people are generally using the learning strategies or whether they generally don't use any. 5-category response scale was used. That was perhaps not the best one to talk about, especially middle response category. But, well, I think that it fits quite well, and we found nothing better in PIAAC data to deal with our problem. So we used 36 countries, 35 is, let's say, base PIAAC, and also USA from the 2017. We used 3 variants of dependent variable using scores on literacy, numeracy, or problem solving. Scores for problem solving are missing in some countries, by the way. And for this first general analysis, only first PV was used to make things simple. We used the same formal specifications as in simulation, that is GPCM with no response style, multidimensional GPCM with extreme and middle response style explicitly defined, IR3 with the same set of response styles, and sum to 0 response style model. And overall, a little more than 300 of models were estimated. So, and so we look at which one fit data the best. It comes out that clear winners are multidimensional GPCM with explicitly defined response styles and IR3s. While multidimensional GPCM won in about 83% of cases, and IR3 in the other ones. There is no considerable differences between traits we used. Differences may be observed between countries. So in one country, so the winning model is often the same for different traits in the same country. And what is perhaps interesting for us most is how changes the relationship between this trait our scale was supposed to measure, that is using learning strategies, and dependent variable, that is our skills. And these bars show how the change between value of this structural path coefficient between model with no response styles and the best fitting model with response styles. So as you can see, there is a considerable variation between countries, with some countries like Korea, Belgium, Kazakhstan, Netherlands, Japan, Hungary. We observed no differences between those two models. Irrespective, quite high differences in quite large differences in model fit. But on the other hand, we've got some countries like United States. Here's this 2017 sample, but 2015 sample is also high in this ranking, let's say. Ireland, Denmark, Italy, Peru, well, where these changes are quite large. So turning to model with response styles makes us observe different strength of relationship between learning strategies and skills. Well, I am running out of time, so I will end quickly. We also made some additional analyses using all 10 PVs and replicate weights to get correct results, simply correct results, and see what's happening within some countries where these differences were the largest. And to sum it up, pattern of response types is quite complex and differs between countries. In most cases, it is quite so, okay, perhaps here in Sweden, it can be quite stable. It is quite stable in a measurement part, but it is different between different skills when it comes to this structural part. So whether response styles are connected with literacy. In Sweden, they are not. In Sweden, however, middle response style becomes correlated with numeracy, but not with problem solving. This is quite complex thing, and well, up to now we have no good explanations for how these complex patterns of response styles differ between countries. Thank you very much, and I hope it was interesting.